Whether a bond is polar and the electrons are shared unevenly or nonpolar and the electrons are shared evenly is one way to determine that is by calculating the electronegativity difference of the two atoms that are in the bond. So electronegativity, or En for short, is the ability of an atom to attract electrons within a bond. We mentioned it earlier when looking at molecules, Vesper shapes. So the higher the electronegativity, the greater the atom has this ability to attract the electrons. And so fluorine is the highest electronegativity with 4.0. It's in the upper right of the periodic table. And as you move to the lower left, these numbers get smaller. Sodium, for example, is 0.9. And each atom has its own value. These are relative values with no units. And they're only used to determine the electronegativity difference, okay, which is to determine the bond polarity if you have a nonpolar or if you have a polar bond. So they're not used to calculate like volume or anything like that, but just to figure out the bond polarity. That's what it's called. Okay, so how well the electrons are shared. Either they're evenly shared and nonpolar, or they're unevenly shared and polar. So the electronegativity difference is you take the two atoms that are in the bond, so you have atom number 1 and atom number 2. You only can have two atoms in a bond, and you look up the electronegativity values. They each have electronegativity values on a table like this. You don't have to memorize them, you just have to know how to use it. And you take those values and you subtract one value from the other. And you take the positive, that's what this bracket means, is an absolute value. It's the whatever the number is from the subtraction, you make it a positive value. Okay, so for example, if I do the hydrogen-oxygen bond, so I take the value for hydrogen and oxygen and I subtract them within this bracket, which is the absolute value. Okay, so I'm going to take the hydrogen value, which is 2.1, and then the oxygen value, which is 3.5, minus 3.5. Now you'll notice because of the absolute value, it doesn't matter that this number comes out negative 1.4. Because of this absolute value, it's 1.4. Okay, so you take whatever the number value is, you make it positive. So therefore, it doesn't matter if you had subtracted 3.5 minus 2.1. It could have been oxygen minus hydrogen or hydrogen minus oxygen. They're both going to end up 1.4. Okay, so then whatever that number value is, it falls into either this range or this range of the covalent bonds. If it is between 0.5 and 1.9, as this 1.4 is, it means it's a polar bond. So this is the uneven sharing. And if it's less than 0.5, so if it's 0 to 0.4, then it is a nonpolar bond. The electronegativity values you don't need to memorize, but these two ranges for the nonpolar bond versus the polar bond, be able to have this handy on reference or memorize it. When you have a polar bond, the electrons are unevenly shared. And what happens is that the electrons are attracted to the more electronegative atom. So the more electronegative atom has the higher electronegativity value, so has a higher En value. And so that means the electrons are pulled towards the atom with the higher electronegativity. So in this example of oxygen, that had the value of 3.5. So the electrons in this bond are attracted to, because oxygen has that high electronegativity, they're attracted to that oxygen atom. So the electrons in the bond are more attracted to the more electronegative atom. And therefore the electrons with the negative charge spend more of their time on the higher electronegative atom, and this results in what this is, a partial negative charge. It's not a full negative charge like an ion, and so this is called delta negative compared to delta positive. So that's a partial negative charge, and this is a partial positive charge. And it's not a full negative or full positive like ions are, because they're still electrons that are shared. Okay, so electrons that are transferred are ions, but these are electrons shared in the bond, so it's just partial negative, partial positive. So that's a polar bond, and what you do is you have an arrow drawn towards the more electronegative atom that has the higher electronegativity value, and that applies to bond in a molecule. So there's two bonds in this water molecule, and so you could draw two arrows. Okay, so two arrows, and they're called dipole arrows. And these dipole arrows point to the more electronegative atom, and that's because the electrons are drawn towards the more electronegative atom and cause this kind of negative field on that atom